Hello, ladies and gentlemen, boys and girls, friends and neighbors. Today we're going to have a little video over factoring quadratic expressions. What is a quadratic expression? A quadratic expression looks like ax squared plus bx plus c. We know that from our study of quadratic functions, and we've looked at those quadratic functions for a time now. Before I get to factoring quadratic expressions, I'd like to review what in the world is factoring anyway. Factoring means to take a product and find the factors that multiply together equal that product. So we're just going to start very simple. If I have this number 15 and I ask, hey, what two things multiply together equal 15? Everybody in this class could certainly say, hey, that's 3 times 5. So 3 and 5, I have factored that. This is going to be 3 times 5 is 15. This is the factorization. 3 and 5 are factors of 15. In like manner, I see 21. Well, 21 is going to be what? 3 times 7. 3 times 7 is 21. Again, 3 times 7 is the factorization of 21. And again, if I look at 48, I could go, hey, well, this is going to be 2 times 24, and that's a factorization, but I have to realize that's not the prime factorization because I can factor 24 even more. So hopefully you remember doing prime factorizations of numbers. I can break the 24 down again. I can find another factorization of that. That's going to be 2 times 12. Okay, and that is a factorization. All of these are factorizations of what I'm going to say are 48. 2 times 24, 2 times 2 times 12, that's a factorization. There are 3 factors here. And then if you can see, hey, I can still do 12 again. So that's just going to be 2 times 2 times 2 times 6. That also is a factorization of 48. And you probably can see where I'm going with this. And yes, I am. I'm going to do yet another factorization, which is going to be 2 times 2 times 2 times 2 times 3. This is also a factorization. This particular factorization is called the prime factorization because all of the factors are prime. And I could actually write 48 this way. This is going to be 2 to the 4th power times 3. This is the prime factorization of 48. That's not to say all of the other factors that I have denoted there are factors, because they are. Okay, because 2 times 24 and so forth is 48. 2 times 2 times 12 is 48. So that's the prime factorization. That's a little review of factoring real numbers. The next review I get that I'm going to touch on before I get to factoring quadratics is, hey, what happens if you multiply? Let me close this screen right here. What if, and I'm only going to look at the left side over here. I'm going to look at this side right over here. That's the side that I want to look at right now. Okay. And what I'm going to do is multiply. Here I have 2 binomial factors. I'm going to factor x plus 3 and x minus 2. I'm going to use the FOIL method, if you will, because most of you remember the FOIL method, and that's fine. I'm going to multiply those 2 things together. Okay, so let's do it. And I get x times x is x squared. X times negative 2 is negative 2x. 3 times x is 3x. 3 times negative 2 is negative 6x. I'm going to simplify this expression. Negative 2x plus 3x is x. And now I have x squared plus x minus 6. That's what this is multiplied together. So if I multiply x plus 3 times x minus 2, I get x squared plus x minus 6. That's multiplying 2 binomials. If I came over here and said, hey, does this expression Can I factor that expression? Can I find two numbers or two numbers that multiply together equal that? Oh, well, right here they are. I can look right at them. The factorization of that guy right there is simply x plus 3, x minus 2. So this is the factorization, and this is what we're going to work on down the road. I have a couple examples. We're going to take some more difficult quadratic expressions in factoring, because I like to start with the most difficult ones, because then that makes the easy ones easy. Okay? So this is what we're going to look at today, how to factor this quadratic, and I'm going to show you how to do that. I know this is the factorizations because this is what I started with. And I can have another example over here. If I have 2x plus 7 multiplied by x minus 1, again, I'm going to FOIL that. 2x times x is 2x squared. 2x times negative 1 is negative 2. 7x minus 7, add them together. I get 2x squared plus 5x minus 7. And if I sit over here and say, hey, what's the factorization? What's the factorization of this quadratic expression? I would say, oh, that's 2x plus 7, x minus 1. This is easy to do if I give you the factors first. But what's going to happen is we're not going to give you the factors first. We're going to start here and end here. And what method are we going to use? We are going to use the AC method. This is the only method that I teach for factoring quadratics because it is the most efficient way. So here we go. I have this expression, 2x squared minus 7x minus 4. Looks similar, and I could guess and check that. I'm going to do some guessing and checking, but not much. And the guessing and checking that we're going to do, hopefully it will eventually become easier. So I'm going to use the AC method. And we already decided when we were looking at quadratic functions, when we were using the quadratic formula, and we used this a lot when we were analyzing the graph of quadratic functions, we found the A, we found the B, and we found the C. And again, we're going to do that for factoring this quadratic expression. And we know that A is equal to 2. We know that B is equal to negative 7. And we know that C is equal to negative 4. This method uses the AC method. So what we're going to do is we're going to find this product, A times C. And this product, A times C, in our case, 2 times negative 4 is negative 8. And what we're going to do, and here's the trick, we want to find two numbers that multiply together to equal this product A times C, which in our case is negative 8 for this particular example. We want two numbers multiply together, negative 8, but we want those same two numbers, and I just use PQ because I like to keep my P's, Q's, and straight. I want those same two numbers to add together to equal B, which in our case is negative 7. So I need to find two numbers that multiply together to equal AC, and the same two numbers add together negative 7. And you're going to get, this is a fairly easy thing to teach because it's pretty straightforward. So here what do I want? I want P times Q to equal negative 8, and I want P plus Q to equal negative 7. Now is the guessing and checking. Now we have to think about two numbers that multiply together negative 8 to add up to negative 7. Made a little typo there. Oh, already got them. You got them? Billy? Jose? Maria? Yes, you're right, Maria. The two numbers are negative 8 and 1. Negative 8 plus 1 is negative 7, and negative 8 times negative 1 is equal to negative 8. pardon me. Negative 8 times 1 is negative 8. So those two numbers were easy to find. So here are the two numbers that I'm going to use. I'm going to use negative 8 and 1. Negative 8 plus 1 is negative 7. Negative 8 times 1 is negative 8. And what I'm going to do here is I'm going to come over here and I'm going to split that up into those two numbers. So I'm going to rewrite the 2x squared here. I'm going to rewrite the negative 4, but now I'm going to use the negative 8x and plus the 1x. So I found those two numbers p, q, and I used those two numbers to separate the linear term here in this quadratic. And now I'm only going to look at these two. Let me do this in yellow. Guys, and these two numbers. And what I'm going to do is I'm going to factor out the greatest common factor. This is called factor by grouping. So I'm going to look at these two numbers right here. And I'm going to look at, hey, what's the greatest common factor of those two numbers? And the greatest common factor of those two numbers looks like is going to be 2x. So 2x times what is 2x squared? X. 2x times what is negative 8x? That's going to be negative 4. And here's the deal. If you actually have found P and Q, see this guy right here? This guy right here has to end up over here. It's going to end up over there every time if you find the P and the Q. So I'm going to take this x minus 4, and I'm going to slide it right here in that box. And I'm going to say, hey, what times x minus 4 is? Oh, x minus 4. And you can see that number right there is a positive 1. 1 times x is x. 1 times negative 4 is negative 4. And now I have two terms. I have 2x times x minus 4. And I have 1 times x minus 4. What I'm going to do is I'm going to factor out the common green circle in both of these terms. So here you go. I have 2x plus 1. And out of that comes this x minus 4. Because I have x minus 4 times 2x and x minus 4 times 1. And this, ladies and gentlemen, this is the factorization of this guy right here. 2x squared minus 7x minus 4. Let's do another example, and you might have to reread this video, reread the video. You might have to rewatch the video. I just had that one. So here's another one. Let's factor this guy. It looks like the numbers are a little bit bigger. That's okay. Step number 1, find the A, B, and the C. A is equal to 3. B is equal to 17. C is equal to 20. Oh, the numbers are big. Find the A times C. A times C, 3 times 20 is 60. The B is 17. So what do I want? I want two numbers, P times Q equals 60, which is equal to A times C. And I want those two numbers, P plus Q equals 17, which is equal to B. Eventually, you'll stop writing this. You'll just right away say, hey, I want two numbers multiplied together equal AC, 60, and two numbers to add together equal B, in our case, 17. Here's the guessing and checking. So you have to think, you have to be a little creative. So you might have to pause. Again, I'll ask Jose, Andrea, Bobby Sue. Anybody got it? Anybody got it? Oh, thank you, Jamal. Jamal came up with those two numbers. Jamal said, hey, man, 5 times 12 is equal to 60, and 5 plus 12 is equal to 17. So now I have found my two numbers. 5 and the 12. And what do? I'm going to take those two numbers and I'm going to put them up here. So I'm going to rewrite the 3x squared and the positive 20. And I'm going to say, hey, I have a 12x, bam, and I have a 5x right here. 12x plus 5x is 17x, so I've not changed the expression. I found those two magic numbers, p and a q. And now I'm going to look at these two terms and these two terms, and I'm going to factor out the greatest common factor. So here I go. If I look at that, what's the greatest common factor? Looks like it's going to be 3x. 3x times what? Well, 3x times x is 3x squared, and 3x times 4 is 12x. And what I'm going to do, ladies and gentlemen, since I did find the p and the q, and that's what's so glorious about this, or what's magical, and it's not math, it's not magic, it's math. I'm going to write this x plus 4 over here because it works every time. And I'm simply going to ask myself a question. What times x plus 4 is 5x plus 20? And it should jump right off the page at you. This is going to be 5. 5x times x is 5x. 5 times 4 is 20. And now again, here's the part that some people have a hard time looking at. I have an x plus 4 and I have two factors. I have 3x times x plus 4 and I have 5 times x plus 4. So what I'm going to do is, again, I'm going to factor out that green circle. And what do I have? I have 3x plus 5. 5 comes there, times what? Times green, x plus 4. And guess what? This is the factorization of this. So I've started off with two fairly more difficult than what most algebra teachers would start off with. And that's okay. I like the AC method. It works really nice. So I'm going to give you one more example to give it a try on your own and see if you can do it. Yes, George, in the back, you can pay attention and you can try this example. You as well, Alexis. So here you go. Here's a final example. 3x squared minus 2x plus 20, 35. So give that a whirl. I'm going to pause the video, pause the video, pause the video. And let's see what you can do. Okay, let's restart the video and let's see here. We got A is 3, B is negative 22, and C is 35. A times C is 105. Let's write that a little bit clearer, if you will, 105. And so and B is negative 22. So I want two numbers multiplied together, this positive 105, and add together negative 22. Think about this a minute, Roy. If two numbers multiplied together equal positive and they add to be negative, they both are going to have to be negative. And indeed they are. And I think, Jamal, you had these again. You've been pretty good with this. And I think he said, hey, this is going to be negative 7 times negative 15. Sometimes 5 is 35, carry the 1, it's 105 positive, and then negative 7 plus negative 15 is equal to negative 22. So that's nice. So we know what we're going to do. We're going to take that negative 7 and negative 15, and we're going to put it under the negative 20. So I have 3x squared, and this is going to be negative 7x minus 15x. Still have this plus 35. Plus 35. Bad job, Lee. That's all right. You make a little mistake. That's okay. And now we're going to factor by grouping. We're going to look at those two rascals, and we're going to look at those two rascals. We're going to realize that's negative. Oh, my goodness. Doesn't look like there's a common. Well, yes, there is. Don't give me that. There is a common factor. The common factor is simply x. And so what do I have? X times 3x minus 7. X times 3x is 3x squared. X times negative 7 is negative 7x. And what do? I write that guy over here. And I'm going to write that in green because I've been doing the common linear factors in green. And when I've simply asked myself a question, what times 3x is negative 15x? Negative 5. You got it. Negative 5. And does it work? Negative 5 times negative 7 equals 35. Yup. Now I'm going to factor the 3x out. And I have x minus 5 is going to equal x minus 5 times 3x minus 7. And voila, this is a toughie. So the factorization of 3x squared minus 22x plus 35 is x minus 5 times 3x minus 7. And that is the end of this 21-minute video. Thank you very much. You might have to re-watch this video. It's not too bad. I think you can get it down. This part right over here, this is going to be the hard part, finding the p and the q, but it's not that hard. All righty. Catch you on the flip side.